I am Avi and welcome to Easy Aviation. Today we will be discussing FADEC in detail. FADEC, or Full Authority Digital Engine Control, is a sophisticated electronic system that precisely manages and optimizes aircraft engine performance. It offers full digital control over various engine parameters, ensuring optimal efficiency, safety, and reliability. FADEC systems enhance pilot ease of use by automating complex tasks and providing redundancy to maintain functionality, even if one component fails. This technology represents a significant advancement in modern aviation engineering. Now let's go to our professor for a detailed explanation.
Hi, thanks Avi for the basic introduction. So now I'll be explaining what the basic integrities about the FADEC system. As you can see, I have divided my complete discussion into three parts: introduction, benefits and drawbacks, and there are few figures. So I'll be explaining more about the figures, and I hope that will cover the complete theory part. So as you can see, this is how a FADEC look like, and FADEC is an electronic control unit, and it is connected with the engine. It takes multiple inputs, and the purple parts are few of many of the inputs, and the green part are the outputs. So I'll just discuss like the fuel, how much fuel presently going inside the engine is one of the parameter taken or read by the FADEC. Ambient pressure, bleed valve position, density of the air, temperature, exhaust temperature, jet pipe temperature, or the combustion chamber temperature of the engine. Lever position, the position of the lever which regulates the fuel, amount of fuel goes into the engine. Ambient temperature, inlet guide vane assembly, how much air is going inside the engine. So inlet guide vane assembly, how much air, so that position of the guide vane is being read by the FADEC. So it processes all these inputs. Process is very high, some 720 times per second. There are multiple channels into the FADEC, 4 channel, 2 channel, in which all these inputs are being read, and accordingly this FADEC gives output in the manner that it regulates the fuel, how much fuel is required, what should be the position of inlet guide vane assembly and other engine parameters. So since the aircraft is flying into multiple regimes, if we speak about a helicopter hovers, at which it takes a maximum amount of fuel, or the load is very high during the hover. The aircraft is climbing, descending. So during all different regimes, the workload or the load on the engine is different, and depending on that load, how much air requirement is there, how much fuel requirement is there, is being controlled by the FADEC. So this is one part. If we speak about the airplane, fixed wing aircraft, again it's climbing, cruising or landing. Different regime has different load requirement, and accordingly fuel and the amount of air required by the engine is regulated. So all this regulation is being done by the FADEC. If we speak about the theory part, it's autonomous control of the engine. Yes, there is no manual intervention, and the complete control of the engine is taken care by FADEC. It's self-monitor, self-operate, redundant and fail-safe setup. Self-monitor, yes, since it is taking values on different channel. If it is a 2 channel, there are 2 values of fuel flow from different sensors, and it monitors and it compare, yes, how much should be the value. Self-operate, it process and gives the output. Yes, redundant, again multiple channels, multiple sensors are there to give the values, so it is redundant, and a fail-safe setup. It leads to optimum engine efficiency. Why optimum engine efficiency? Because there is no human intervention first, and it complete process is autonomous, it's electronic. All the sensors which are giving value, it is being processed, and accordingly exact amount of fuel and IGV operation is being done. That's why the engine efficiency is to the best. Benefits, yes, it's lower the workload on pilot. Yes, definitely. Cost effective because engine efficiency is high. Manufacturer can program engine limitations. So yes, there are few limitations, few interlocks about the engine which is required, like if the RPM goes very high of the engine compressor, engine should shut down. So such kind of interlocks can be fed into the FADEC, and accordingly this thing can be processed. Handy engine health maintenance report. Health maintenance report, as in, yes, all these parameters is anyhow being read by the FADEC and being recorded, and that's why after each sortie, after each flying, these parameters can be recorded, and a health maintenance report can be read. Drawbacks, since there is no manual override, FADEC failure means the engine failure. Previous version, which is also known as DECU, Digital Engine Control Unit, or ECU, in those there is manual fuel control lever was there, MFCL kind of thing, in which the fuel can be controlled in case of FADEC failure. But now newer version of the FADEC, this is completely autonomous and there is no manual intervention. Once the FADEC fail, there is no control over the engine. In note, I'll just additional point, in case FADEC fails, it set the fuel flow at a particular load requirement. There's a high load requirement, low load requirement. So what happens basically when the FADEC fails, the lever position which regulates the fuel, that gets stuck or that gets freeze. So once that lever is frozen, there's one, let's say, X amount of fuel which is continuously going inside the engine, and now you have to control the aircraft performance depending on that load requirement. So that is a completely deep understanding. So that is one thing which I'm saying. FADEC fails, engine fails means the engine is stuck at particular load requirement. Now coming to this curve and a little bit more in-depth knowledge about the FADEC. So as you can see, if you have read, this is a compressor curve and there is a air mass flow on the x-axis and pressure ratio. So if this is a compressor, this is P1, let's say, and this is P0. So pressure ratio is P1 by P0 and air mass flow is the amount of air which is going inside. So these curved line are the constant RPM line at which the engine is running. So if we, let's say, if we take this RPM line, aircraft is running at, let's say, 2200 RPM, 2200 RPM. The amount of air mass flow and the pressure ratio on X and Y axis is given by this curve. This is a surge line. So in any case, if air mass flow is more, if fuel inlet is more, leads to more air mass flow, or the IGVU is open more, may leads to higher pressure ratio, may cause the complete engine to go into surge. So to avoid that, the FADEC regulates, take all the parameters I already discussed, and ensure that engine should run as closer as to the surge line to give the best efficiency, and not let engine to go into surge line. So this is the major, you should say, major duty of the FADEC, that efficiency should be high, because if engine can operate here for the safe zone, but the efficiency will be too low. So for the efficiency to go higher, engine should work as near to the surge line, but should not also go beyond the surge line, otherwise engine will shut down and other issues will come. So this is about the FADEC. I hope you have understood a bit about more to your existing knowledge. If you want me to cover any other topic related to aviation, please let me know. Let us all make aviation easy. Thank you for subscribing. Please share to your friends. Thank you.